Now see few example based on dielectric, how the dielectric effect on a capacitor. Let example number 1, a parallel plate capacitor, of capacitance 2 microfarad is charged across 100-volt battery. Now it is connected with a uncharged capacitor of capacitance 3 microfarad as shown in diagram. See here. First of all, this is a capacitor. Let capacitance here 2 microfarad. This is charged with a 100-volt battery and it is connected with a uncharged capacitor of capacitance 3 microfarad with the help of a battery. This is given. Now switch as close, then find the charge on each capacitor. This is the part. Next, first part. Now switch S open and space between the plates of capacitor C1, between the plates of capacitor C1 is filled with a dielectric constant K, then switch S close, find the heat developed in the process, heat developed in redistribution of charge. So this is the question here. See the solutions here. First thing is that it is given that this is a capacitor of capacitance 2 microfarad. It has been charged with a 100-volt battery and it is connected with a switch S and a uncharged capacitor of 3 microfarad. First the switch S close. So when the switch S close, since this capacitor was uncharged, charge will flow between these two capacitors till both are not reaching at the same potential. After that, charge flow stop. So after closing switch, in the first step, after closing switch, now see the diagram. This is the diagram C1, C2. Let charge on this your Q1 and here charge at your Q2. Now we can apply Kirchhoff first and second law. So initial charge means when it was charged by 100-volt battery. At this moment, charge on this your 200 microcoulomb. So whatever charge on this plate, that can go on this plate only. So whatever distribution of charge will take place between these two plates. So initial charge on this plate was 200 microcoulomb, like that. And now final charge means after closing the switch. Here charge I assume Q1, here Q2. So first equation we can have Q1 plus Q2 is your 200 microcoulomb. This is the first equation. Second equation we can get by applying Kirchhoff second law. So minus Q1 by C1. So minus Q1 by C1, C1 value is your 2, plus Q2 by C2, Q2 by C2 value is 3, which is equal to 0. So from here we can get Q1 is equal to your 2 by 3 Q2. This is the second equation. From these first and second equation, we can calculate the value of Q1, Q2, the C. From above two equations, substitute the value of Q1, 2 by 3 Q2 here. So you will get 5 by 3 Q2. This is 200 microcoulomb. So Q2 is 120 microcoulomb and Q1 will be, if Q2 your 120 you can put here. So Q1 is your 80 microcoulomb. So this is the initial charge after closing the switch S. Now come to the first part of this problem. Now switch S open. Now switch S again open, and space between the plates of capacitor C1 is filled with the dielectric constant K. So see for the first part. For the first part, now switch S open. So right now switch S open like this, and C2 is this one. Now C1. So now since dielectric constant K, then switch S close. So when it has been closed with dielectric constant K, we can assume K is any certain value, let K is equal to 2. So when it has been filled with the dielectric constant K is equal to 2, so now new capacitance will be your 4 microfarad and C2 will remain your 3 microfarad. So after that what happened? Since it has been closed, during the space when it has been filled, charge will not flow. The charge on this will remain same here Q2, and here it will be your Q1 initially. Now after filling the dielectric constant, now when the switch S has been closed, then again because of the change in the potential difference between these two plates, due to the effect of dielectric, charge again redistribute. So when charge again redistribute, then in this process final charge, or we can calculate common potential, V common is equal to total charge Q1 plus Q2 by total capacitance C1 plus C2. And Q1 plus Q2 is nothing, it is your total 200 microcoulomb, and C1 dash plus C2, C1 dash become now 4, C2 is your 3, so this become your 7 microfarad. So potential will be your common potential will be here 200 by 7 volt. So this is the final potential. After that we can calculate the heat. So for heat we can use the equation initial energy stored in the system. Here no battery, no work done, is equal to final energy plus heat. So initial energy means when the charge was Q1 and Q2. At that time, total energy stored in both the capacitor, half Q1 square by C1 plus half Q2 square by C2 is equal to final energy when the potential on this is 200 by 7 volt on each of the capacitor. So then we can calculate the final potential energy and plus heat. The difference of these two energy give the heat amount. This is the one of the question here. Now see another example. Okay, now this is the question here. In this circuit, capacitor have capacitor your 1 microfarad. It has been charged up to 50 microcoulomb initially. It is connected with a cell of EMF 100 volt along with another capacitor of capacitance 4 microfarad, and it has been filled with the dielectric of dielectric constant K is equal to 2 and initially switch S was open. So first part of the question is that find the charge on each capacitor after closing switch S. This is the first part. In the second part, we have to calculate. Now, dielectric slab has been removed from capacitor C2 and it is filled between the plates of capacitor C1. Between the plates of capacitor C1, find the charge flow in this process. Charge flow in this process. This is the simple problem here. See, in the first part, find the charge on each capacitor after closing switch. So in that case, when the switch has been closed, finally the flow of charge will stop when both of these are reaching at same potential. So we can make a diagram like this. This is your 100 volt battery and here it is given initial charge or 50 microcoulomb. Let after distribution of charge remain only Q1 and here let charge Q2. This is just our assumption. And capacitance of this given your 1 microfarad and this capacitance your 4 microfarad along with the dielectric. Now first equation. By using conservation of charge, see these two plates. These two plates are connected together. So whatever charge on these two plates, that will flow only between these two. So initial charge was your minus 50 and final charge here minus Q1 and this is your minus Q2. So minus Q1 minus Q2 your minus 50. This is your first equation. Second equation we can use by applying Kirchhoff's second law. Now we can start from here. Minus Q1 by C1 plus Q2 by C2. So minus Q1 by C1 means 1 plus Q2 by C2. Q2 here we have to find and by C2 your 4 and then minus 100, that is equal to your 0. Second equation, and this equation further we can modify it. Minus Q1 plus Q2 by 4 is your 100, or we can say Q2 minus 4 Q1 is your 400. This is your second equation. Now with the help of first and second equation, we can get the value of Q1 and Q2. Just substitute the value of Q2 from the first equation. The Q2 written as minus Q1 plus 50. Minus Q1 plus 50 minus 4 Q1 is your 400. So minus 5 Q1 is your 350. So Q1 value comes here minus 70 microcoulomb. So charge on this here minus 70 microcoulomb. Minus sign indicate the polarity has been changed. Now substitute the value of Q1 here. So Q2 value will be Q2. Q2 is your minus Q1 plus 50. Minus Q1 plus 50. So minus Q1 value your 70. This is your 120 microcoulomb. So finally what we are getting, the charge on each capacitor is like this. So this is the distribution of charge, the finally charge. As shown here, Q1 your negative, it means this is your positive and negative, and that value your charge 70 microcoulomb, and Q2 value your 120, this is your minus, this is your plus, Q2 is your 120 microcoulomb. And we can check it by using conservation of charge. Here minus 50 is there, here plus 70 and minus 120. Total charge including in these two plates here minus 50. Now next, in the second part they are saying, now dielectric slab has been removed from capacitor C2 and it is filled between the plates of capacitor C1. So what is the effect on how much charge will flow in this process? See, now dielectric slab has been removed from this capacitor to this capacitor. So new capacitance, as soon as it has been removed, since the K value is given here 2, so capacitance of this become C2 dash, which is your 2 microfarad, and now it has been filled in the C1. C1 which earlier it was your 1, because of the dielectric slab, the new capacitance C1 dash, the C1 dash will be 1 into 2, 2 microfarad. So now the new charge distribution we want here. See, let the new distribution of charge may be like this. (100-volt) battery is there, and initial charge on this here minus. So I took here charge here Q1 dash, and this charge you let Q2 dash, and here capacitance of this here 2 microfarad, and this capacitance is also 2 microfarad. Now again we can use conservation of charge, because these two plates are connected together. Whatever charge, that charge can flow only between these two plates. So in these two plates, initial charge was plus 70, minus 120, it means minus 50. The initial charge was your minus 50. Now charge is your plus Q1 dash minus Q2 dash. So Q1 dash minus Q2 dash. This is the first equation. Second equation we can get by using Kirchhoff's second law. See, the Q1 dash by 2, then plus Q2 dash by 2, then minus 100 is equal to 0. So this we can written as Q1 dash plus Q2 dash is your 200. This is your second equation. And now we can simplify from the first and second. From equation first and second. So this we can add this one, the Q1 dash Q2 cancel. This 2 Q1 dash here 150. So Q1 dash is your 75 microcoulomb, and Q2 dash is Q2 dash will be your Q1 dash 75, Q2 dash will be your 125 microcoulomb. So this is the final charge. Final charge means here Q1 dash is your 75 microcoulomb and Q2 dash 125 microcoulomb. Now check it. The question is that how much charge flow in this process. Initial charge means without changing the dielectric slab. Charge on this was your minus 70. Now here charge your minus 50. So how much charge flown in this side? So total charge your minus 5 microcoulomb has flown in this side or through the battery, or we can say plus 5 microcoulomb flown in this side. Anything we can say, either plus 5 microcoulomb has flown in the anti-clockwise direction, or we can say minus 5 microcoulomb has flown in the clockwise direction. So this is the general idea about effect of dielectric between the plates of capacitor.